So in addition to using factor change to interpret results from Poisson regression models and similar count regression models, we can also use what is called discrete change and discrete rates of change. And in this slide, I'd like to introduce discrete change in expected count or expected rates. So let's look at first the expected rates. So expected rates of counts given covariates is equal to the exponential function of x beta. So here the expected rate is the conditional expected rates given xk. Here is a generic variable set to be equal to x subscript s, meaning the starting value of xk. And here, what I'm going to do is just to vary the values of this generic variable xk, only xk. Okay? And then we have another expected rates or expected count is the conditional expected rates given xk. This generic variable given xk is set to be x subscript e, or the ending value of xk. And let xk change from xk subscript s to xk subscript e, starting value to ending value. And the difference in xk, x subscript e minus xk subscript s is delta. Then we can take a difference, right, of these two expected rates to get this discrete change in the expected rates or expected counts. Okay. For interpretation, we can say for a change in this generic variable xk from x subscript s to x subscript e, the expected count changes by delta e. That is the difference in the two expected counts, holding all other variables at given values. So here's a major difference between the interpretation of discrete change and factor change. In factor change interpretation, we can see, well, holding all other variables constant, and we're supposed to say that, right? Since the final result does not involve any other covariates, and doesn't matter where we hold all other covariates, okay? But in this case, for discrete change in expected count, and later is in predicted probability, we had to know where we hold the covariates to be, where are the values of covariates, okay? So in this case, the magnitude of the discrete change depends on the levels of all variables in the model, okay? Not simply this generic variable xk of our interest, okay? Similarly, we can also calculate discrete rates of changes, okay? So the discrete rates of change for a change of delta in xk equals, okay, a ratio, okay, of the delta, that is difference in the expected counts, over delta in the generic variable xk, which is equal to, well, in the numerator, we have the difference of the two expected counts, okay? Holding all other covariates at given or known values. And typical known values are mean or median, etc. But in this case, we only vary the value of xk from x subscript s to x subscript e, starting value to the ending value in the numerator. Okay? In the denominator, we have simply the difference in the two values of xk, that is x subscript e and x subscript s. Here we're talking about xk. Okay. This result can be interpreted as xk changes from x subscript s to x subscript e. We would expect that the discrete rates of change in the expected rates is roughly this ratio, delta e over delta xk, on average, holding all other variables at given values. These given values are known values. Okay?